go class. Chapter 1, write an electric charge and electric field. It's 112 marathon. Chapter 1, electric charge and electric field. Electric charge and electric field is chapter 1. Electric charge and electric field. Two, Gauss law. Gauss, G-A-U, apostrophe S. G-A-U, double S, apostrophe S, law. This is chapter 2. 3, electric potential, electric potentials. 3 what? Electric potentials. 4, capacitance. Capacitance. 4 what? Capacitance. 5, current, electricity. Current electricity. 5, current electricity. 6, DC circuit and instrument. DC circuits and instruments. DC circuit and 7, magnetism. 7, magnetism. Magnetism. 7, magnetism. Hello, please. Okay, to those guys, I don't need that noise. Hello. 8, sources of magnetic fields. Sources of magnetic fields. Sources of magnetic fields. 9, electromagnetic induction. Electromagnetic inductions. 10, alternating current circuits. 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 Class, without wasting much time, let's channel our focus to chapter 1, electric charge and electric field. Quickly, electric charge and electric field. Can I clear the board? Can I clear the board? Please, fast. Please be fast, be. Class, let us start with electric charge and electric field. Electric charge and electric field. Class, the quantity of charge that is passing through a particular surface area is represented with the symbol Q. Class, we're talking about electric charge and electric field. Talking about quantity of charges. How are charges generated? Class, charges are generated when there is what? When there is transfer of electron from one material to another, charges are generally generated. So the quantity of charge generated, class, is the number of the particle n times the electron charge, electronic charge E. The first formula for quantity of charge is Q equals to N, where Q represents the quantity of charge, Q represents the quantity of charge, N represents number of particles, E represents the electronic charge, Class, as a matter of fact, the quantity of charge on one electronic charge is a constant and is given as minus 1.6 times 10 raised to minus 19 Coulomb. Minus 1.6 times 10 raised to minus 19 Coulomb is the value of E. E is minus 1.6 times 10 raised to minus 19 Coulomb. E. Class, let's take a question to this regard. Alright, take this question down. A plastic rod. A plastic rod is rubbed. A plastic rod is rubbed against a wool shirt. A plastic rod. A plastic what? Is rubbed. Is what? Rubbed against a wool shirt. Against a wool shirt. A plastic rod is rubbed. Is what? Rubbed against a wool shirt, thereby acquiring a charge. Thereby acquiring a charge. Thereby acquiring a charge. Thereby acquiring a charge of minus 0.8 microcoulomb. Thereby acquiring a charge of minus 0.8 microcoulomb. Thereby acquiring a charge of minus 0.8 microcoulomb. How many electrons are transferred from the wool shirt to the plastic? How many electrons are transferred from the wool shirt to the plastic? How many electrons are transferred from the wool shirt to the what? Plastic. Come again, the plastic rod is rubbed against a wool shirt. A plastic rod is rubbed, is what? Against a wool shirt. Thereby acquiring a what? Charge of minus 0.8 microcoulomb. Thereby acquiring a charge of minus 0.8 microcoulomb. How many electrons are transferred from the wool shirt to the plastic? Class, have you noticed that if you take a comb and you use to rub your hair several times, you rub your hair several, and you take that comb and pick and attach to a piece of paper. It will pick up the paper, right? Class, same thing happens when you rub a plastic rod against a wool shirt. Charges will be what? Generated. Electrons will be transferred. We are asked to calculate how many electrons are transferred from the wool shirt to the plastic. Yes. So when the plastic rod was rubbed against the wool shirt, a charge of minus 0.8 microcoulomb was acquired. So quantity of charge acquired is minus 0.8 microcoulomb. But class, we know that micro means 10 raised to minus 6. So this is the same thing as minus 0.8 multiplied by 10 raised to minus 6 coulomb. Minus 0.8 multiplied by 10 raised to minus 6 coulomb. Thank you. So we just change micro to 10 raised to minus 6. Class, that micro there represents what? Multiplied by 10 raised to minus 6. Class, we were asked how many electrons are transferred. So they asked us to find number of electrons. Class, this n could stand for number of particles or number of what? electrons or number of atoms. Class, anytime you say find number of something is n, you are looking for n. So we have Q. Q is minus 0.8 times 10 raised to minus 6. Q is minus 0.8 times 10 raised to minus 6. Class, E is a constant. Nobody will give you E is a constant. E is minus 1.6 times 10 raised to minus. So you have Q, you have E, you are looking for N. We're going to make N subject of the formula. So if Q equals to NE, what should be N? N must be equal to Q all over E. N must be equal to what? Q all over E. And what's our Q? Minus 0.8 times 10 raised to minus divided by E, minus 1.6 times 10 raised to minus 19. So we have minus 0.8 times 10 raised to minus 6 divided by minus 1.6 times 10 raised to minus 19. Class, let me now tell you something. Someone should be asking me, why do we have this minus in electronic charge? Well, I deal with electrons. Electrons are negatively. Class, they might want to surprise you in the exam and ask to find the number of particles transferred for a proton. Class, if this question was talking about a proton, there will be a negative sign in the electronic charge. Class, for a proton, the electronic charge does not carry a negative, but because protons are positively charged particles, right? Electrons are negatively charged. So if this were to be a proton, do not put this negative, class. Are we together? What's the final answer? Minus cancels to minus. If you do it very well, you should have 5 times 10 raised to 12, right? So this is the number of electrons that was transferred. This number of electrons that was. Class, do not expect more stories in this course. This physics, small calculations. See, I didn't bother going into too much stories. Straight to calculation. Straight to what? Calculation. Now, quickly, write this down. Let's take another question. Let's take another question. Quickly. A small copper plate has a mass of 3 grams. A small copper plate has a mass of 3 grams. A small copper plate has a mass of 3 grams. A small copper plate has a mass of 3 grams. A small copper plate has a mass of 3 grams. Given that the atomic number of copper Z is 29, given that the atomic number of copper Z is 29, given that the atomic number of copper Z is 29, given that the atomic number of copper Z is what? 29, given that the atomic number of copper Z is, and the atomic mass is 63.5 gram per mole, and the atomic mass is 63.5 gram per mole, and the atomic mass is 63.5 gram per mole, and the atomic mass is what? 63.5 gram per. What is the total charge of all the electrons in the copper plate? What is the total charge of all the electrons in the copper plate? I'll come again, right? Let's come again. Let's go again. A small copper plate. A small copper has a mass of 3 grams. Has a mass of 3 grams. The atomic number of copper Z is 29. The atomic number of copper Z is 29. And the atomic mass is 63.5. And the atomic mass is 63.5 gram per mole. What is the total charge of all the electrons in the copper plate? What is the total charge of all the electrons in the copper plate? Is that better? Okay, class, good. Now, follow me. Class, similar formula we're going to use, but different process. Q equals to NA, class. But anytime you are asked to find total charge in a copper, in a metal, class, you must consider how many electrons that metal contains. We are going to consider how many electrons are in that metal. Class, there's a reason why they gave us the atomic number of copper. Because you think, are we doing chemistry? Why are they giving me the atomic number of copper? Class Z 29 has given you the atomic number. And atomic number means number of protons, right? But class, we are aware that when elements are on charge, they have equal number of protons and electrons. So if copper has 29 protons, it therefore means that copper also has 29 electrons. Does that make sense, class? If copper has 29 protons, it also has 29 electrons. So class, that means that the number of electrons in copper is 29. That's not all. Class, we have to find a small copper plate of mass 3 grams. Mass 3. So the mass of the copper plate is 3 grams. Class, we need to ask ourselves, how many atoms of copper can be found in 3 grams of copper? Class, follow me. How many atoms of copper can be found in 3 grams of copper? Class, based on the Avogadro's number, we know that 1 mole of any element or any substance contains 6.02 times 10 raised to the power 23 atoms or particles. Do you remember?
Yes.
That 1 mole of any substance contains 6.02 times 10 raised to the power 23 atoms or particles. Now, class, we're also aware that 1 mole of any substance is equivalent to the molar mass of that substance. Do you agree? The molar mass or the atomic mass is an element. And what is the atomic mass of copper they gave us in the question? It's 3 point. It's 3 point what? If 1 mole equals to this, and 1 mole is also equals to this, it means this equals to, it means it's 3.5 grams of copper will contain 6.02 times 10 raised to the power 23 atoms of copper. Do you agree? So 3.5 grams of copper will contain 6.02 times 10 raised to the power 23 atoms of copper. But class, the question gave us just 3 grams of copper. How many atoms will now be found in 3 grams of copper? Because it's 3 grams of copper we're dealing with. Class, do you know what we're doing? The question asks us for a total quantity of charge in 3 grams of copper. Total quantity of charge in 3 grams of... Now, the formula is Q equals to NE, where N is the number of particles and E is electronic charge. Class, before we can find total quantity of charge in 3 grams of copper, we must ask ourselves, how many particles does 3 grams of copper contain? How many atoms does 3 grams of copper call? And that's what we're doing here. So the first question was straightforward, the second question is not straight. So when they're giving you an element class, they're giving you the mass and the atomic mass, this is how you go about it. So you tell yourself from your chemistry foundation, that's a 3.5 gram, the atomic mass of copper, the full 1 mole, which is 3.5, right? We contain Avogadro's number 6.02 times 10 raised to the power 23 atoms. So what of 3 grams of copper? How many atoms will it contain? We call it what? X. We don't. Follow carefully, follow. By Coulomb cross multiply, so 3.5 times x is 3.5x equals to 3 times 6.02 times 10 raised to the power 23. Making exercise the formula, divide both sides by 3 points. So we have 3 times 6.02 times 10 raised to the power 23 divided by 3 points. What are we going to have? Someone should help us? Do you have something like this, 2.84 times 10 raised to the power 22 atoms? Class, this is the number of atoms and 3 grams of copper. Because the question said, what's the total charge of all the electrons in the copper plate, in the 3 grams of copper plate? Total charge of all the electrons. Before we can know total charge of all the electrons in copper, we must find out how many atoms of copper are in all the 3 grams. This is number of atoms. Number of what? Class, another thing we need to do is, this is the number of atoms in 3 grams of copper plate. Class, if copper contains only 1 electron, what will be the charge of 1 electron? I've told you before. Minus 1 point times 10 raised to minus. This is the charge on 1 electron. This charge on what?
1 electron.
But does copper have only 1 electron? How many electrons does copper have? 2. Copper has 2 electrons. He has 29. He has 20. He's still on the board. Look at it. Atomic number of copper is 29. Atomic number means number of proton, right? So number of proton must equal to number of element. As long as the element is on charge. So we have 29. So, if the charge of 1 electron is minus 1.6 times 10 raised to minus 19 Coulomb, what of 29 electrons? What will be the charge on 29? 29 times 29 what? Times minus 1.6 times 10 raised to minus. Because for 1 electron is this. What of 29? That will be 29 times this. Do you agree, class? If the charge on only 1 electron is minus 1.6, follow me carefully. Follow. If the charge on only 1 electron is minus 1.6 times 10 raised to minus 19, what would then be the charge on 29 of them? You multiply 29 multiplied by minus 1.6, right? Times 10 raised to minus 19. Do you agree? Yes. That will give us what? Minus what? Minus 4.6 times minus 18 Coulomb. Plus, this is the electronic charge on 29 electrons for copper. This is electronic charge on 29 electrons for, and this N number of atoms in 3 grams of copper, 2.84 times 10 raised to 22. This is number of atoms in 3 grams of. If we have N and we have E, can we not get the total quantity of charge? Can we not get the total quantity of charge? Class, you need to be with me. Are you lost somewhere?
Yes.
If you are lost, say it now.
Yes, sir.
Just like kidnapper kidnapping someone, and the people that they kidnap, they say, have you been kidnapped? You say, talk now. Please, if you are lost, you say it. Be free to tell me, so please, you are lost somewhere. But it's normal. I'll be surprised if you are not lost. It's normal. But you just started the pause. It's normal. It's what? Class, can we finish first, then we'll come again? Good. N is this, E is this. So Q equals to N, E. Who is N? 2.84 times 10 raised to 20. Multiply by E. Who is E? Minus 4.64 times 10 raised to power minus. Do the math. This times this. Total quantity of charge will now be what? You have something like this. Minus 1.32 times 10 raised to power 5 Coulomb. Minus 1.32 times 10 raised to power 5 Coulomb. Total quantity of charge. You have something like this. Minus 1.32 times 10 raised to power 5 Coulomb plus minus 1.32 times 10 raised to power 5 Coulomb. Do you have something like this? Good. Final answer. We are lost, I'll come again. We are lost, I'll come. Class, we are coming again now. Second explanation. Let's explain again. Looking at the question, a small copper plate has a mass of 3 grams. A small copper plate has a mass of 3 grams. The atomic number of copper is Z equals to what? 29. They give us the atomic number of copper Z is 28. And class, we are aware that the atomic number of an element also gives us information about the number of proton, right? And if you have got a number of proton, you have also got a number of electrons. And since we are dealing with electricity, our major focus is the electron, not even the proton. Because what causes a formation of electric charge is the transfer of electron. Once electrons start moving, a charge is generated already, class. Once electrons start moving, charges are generated. So class, we now know that copper has 29 electrons. I've said this many times now, right? Good. We now need to ask ourselves, but the charge on only one, why someone used to have only 1 electron? What's the charge on 1 electron? Minus 1.6 times 10 raised to minus. Now imagine someone having 29. What would it be? 29 multiplied by, and this is the charge on 29 electrons of copper. Are we together, class? That aside. So because we get the total quantity of charge, we need number of particles, atoms of copper, and the electronic charge on all the electrons of copper. The electronic charge on all the electrons of copper is what we got here, class. We got it by multiplying the 29 electrons and copper times the charge on each electron. Total electron charge. Are we together? Yeah. Coming here now, we also needed to get how many atoms of copper are present in 3 grams of copper. We now recall Avogadro's number. I'm sure if we're given this question, none of your mind will ever have gone to Avogadro's number in physics, right? And we're doing physics, why are we doing Avogadro's number? So you see why sometimes for the first time of the course, it's good for someone to teach you, carry you along first. Like there's one student somewhere, one or now, struggling to read this chapter 1, and asking herself, which one concern Avogadro's number? You've been asking cracking your brain. Why do you bring Avogadro's number in physics? How concern Avogadro's number in physics? Because you see, if your textbook, you are lost. Then you now understand why. That we needed to find the number of atoms in 3 grams of copper. We asked ourselves, this that make mass, the full 1 mole of copper is, 1 mole of copper contains 3.5 grams that make mass of. The full 3.5 grams of copper must contain the Avogadro's number. It's a constant, we know that, right? That's 3.5 grams will contain 6.02 times 10 raised by 23 atoms of copper. Since 3.5 grams will contain 6.02 times 10 raised by 23 atoms of. We now out of 3 grams, how many atoms we found in 3? If it's 3.5 contains 6.02 times 10 raised by 23 atoms. Out of 3 grams, we don't know, we call it what? Since we don't know, we call it what? What would you do to cross? So 3.5 times s is 3.5s equals to 3 times 6.02 times 10 raised by 20. Making x rest of the formula, x must be 3 times 6.02 times 10 raised by 23 divided by 63 points. And we have the number of atoms in 3 grams of copper. Now that we have got the number of atoms in 3 grams of copper, and we have the electronic charge in 29 electrons of copper, Q, our food is done. Food is ready. Food is ready. So Q equals to NE. N is this. E is this. Multiply N by E, and you arrive here. Total quantity of charge. Is that better now? Is it better now? Okay. Let me assume that you don't just feel like talking. Let's move forward. Let's move. Maybe you are saving your strength for exam. It's good. Class. Let's look at right now. Conductors, insulators, and semiconductors. Conductors, insulators, and semiconductors. Conductors, insulators, and what? Semiconductors. Conductors, insulators, semiconductors. Conductors, insulators, and semi what? Let's start with conductors. Conductors, these are substances which allow electric current to pass through them. Conductors, these are substances which allow what? Electric current to do what? Pass through them. It's not recording. No, it's recording. It's recording. It's recording. Example, we have metals and electrolytes. Metals and what? Example, we have metals and electrolytes. Metals and what? Electrolytes. Insulators, rather insulators. These are substances which do not conduct electricity. These are substances which do not conduct electricity. Example, we have non-metals such as glass, rubber. Non-metals such as what? Glass, rubber. These people will not conduct what? Electricity. So if you take a rubber now and go to your straight transformer, will it conduct? Class, yes or no? Yes. As a physics student, you tell yourself, they have taught me. Rubber do not conduct. Give me that rubber, I'm going to transformer now. I'm going to the what? Go to your assignment. You take a rubber, go to your feed transformer, it doesn't conduct what? But in Nigeria, you will not like to try it, but actually it will not shock you. It will not do what? Should I try it? Yes. This what I'm teaching now, where we are, I believe you what will happen. I'm going to try it now. Are we together? So just take a very good rubber. Are we together? With small anointing oil. Are we together? So that when your power head, the Holy Ghost can take. But why do we doubt what we are being taught then? If we say a rubber will not conduct what? Where a rubber glove, On the light, tell NEPA to bring the light. Call NEPA. Touch the what? A naked wire, touch it. Class, no matter of fact, to actually not conduct. Have you seen NEPA climbing pole where there's light before? Yes. They climb the pole and they connect. It won't conduct, it's just fear. Joke aside, to not. I said that rubber, means they sent that rubber from your village. I was together, I said, today we will deal with you. You won't touch light, we'll be looking for you since. Are we together? But actually, it should not conduct. You see now people connecting lights. Have you seen a case where an electrician is holding wire like this? There's light inside, he's holding it because he's wearing this thing. If not, don't they used to use all those pliers to touch light and they bring it? Is it shocking the electrician? They use pliers to touch light, that is right? Because the pliers handle is rubber insulated. It will not shock the electrician. Maybe we went too far, so we went to the transformer. Start with small wire. If it goes, so that will be semiconductors. We are coming there. We are coming to semiconductors. The potential difference, the temperature can make it either conduct or not. We are coming there. That's the third one. Yes. Now, class. Let's go to semiconductors. Semiconductors. These are substances which conduct electricity at increased temperatures. Semiconductors. These are substances which conduct electricity at increased temperatures, but are insulators at lower temperatures. Semiconductors. These are substances which conduct electricity at what? Increased temperatures, but are insulators at lower temperatures. These are substances which conduct electricity at increased temperatures, but are what? Insulators at lower temperatures. Example, we have silicon and germanium. So for semiconductors, they are in between. At higher temperatures, semiconductors conduct electricity. At lower temperatures, they become they do not conduct. So at lower temperature, they don't conduct. At higher temperature, they do what? They conduct. But this aspect of electricity we are looking at is known as electrostatics. Electro what? So at this point, we're just looking at the study of point charges at rest. We have not yet looked at moving charges yet. So this aspect of physics is called electro. Now write down laws of electrostatics. We have two laws of electrostatics. Laws. There are two basic laws of electrostatics, and I think you must have heard one of them before. One, laws of laws of what? One, are we there? You've read this before, I'm sure. Like charges repel and unlike charges attract. The first and ultimate law of electrostatics is that like charges do what? Like charges repel, unlike charges attract. Like charges repel, unlike charges attract. Like charges repel, unlike charges attracts. Two, are you there? The net amount of charge produced in any process is zero. The net amount of charge produced in any process is what? Zero. This is known as the law of conservation of charges. The law of conservation of what? Charges. The net amount of charge produced in any process is what? Zero. The net amount of charge produced in any process is zero. It is known as what? The law of conservation of charges. The law of conservation of charges. Class quickly, we'll go to Coulomb's law. Coulomb's law. Coulomb's law. Coulomb's law states that Coulomb's law states that the force of attraction or repulsion. Coulomb's law states that the force of attraction or repulsion. Coulomb's law states that the force of attraction or repulsion exerted by one point charge on another states that the force of attraction or repulsion exerted by one point charge on another is directly proportional. The force of attraction or repulsion exerted by one point charge on another is directly proportional to the product. Is directly proportional to the product of the charges. Is directly proportional to the product of the charges. And inversely proportional to the square of the distance between them. And inversely proportional to the square of the distance between them. And inversely proportional to the square of the distance between them. And inversely proportional to the square of the distance between them. And what? Inversely proportional to the square of the distance between them. Are we together, class? Class, we have 2 point charges, Q1 and Q2. We have 2 point charges, Q1 and what? Separated by a distance R. Let R be the distance between these 2 point charges. Class, these charges could be attracted to each other or repulsive to each, depending on what, whether they are the same or they are different. Remember the first law of electrostatics said that like charges repel, unlike charges. So this will be a force of attraction. If this is a positive charge and this is a negative, it will be a force of attraction. But to be a force of repulsion, if the charges are the same, positive, positive, or negative, negative, they will repel each. That's why the Coulomb's law said attraction or repel. So the bottom line is that there will be a force between them. Let the force be F, class. Class, Coulomb's law explains the relationship between the force between 2 point charges, F, telling us that it is directly proportional to the product of the charges Q1, the first charge, and Q2, the second, and inversely proportional to the square of the distance between them. So according to Coulomb's law, class, F is proportional to Q1, Q2 all over R squared. R what? Where R represents the distance, F represents the force. Class, a constant must come in anytime you have proportionality sign, a constant must come. That constant is known as the Coulomb's constant K. K Q1, Q2 all over R. Class, the Coulomb constant K, as we said, the constant is 9 times 10 raised to the power 9 Newton meter square per Coulomb square. 9 times 10 raised to the power 9 Newton meter square per Coulomb square. 9 times 10 raised to the power 9 Newton meter square per Coulomb square. 9 times 10 raised to the power 9 Newton meter square per Coulomb square. Are we together, class? Class, if you don't want to use K, the value of K can also be obtained by saying 1 all over 4 pi E naught. 1 all over what? Where E naught represents absolute permittivity. Absolute. Class, permittivity is how much electricity is permitted by the medium. How much electricity is permitted by the medium. Absolute permittivity is the one we use for free space and is a constant class. Class, how much electricity is permitted by this free space is known as absolute, and it has a value of 8.8 times 10 raised to the power what? Minus 12. Actually 8.85 times 10 raised to the minus E naught. E Like I said, this physics don't expect too much stories or notes. It's more of calculations, formulas and apply. Formulas apply. Question to apply them. So after giving a formula, we'll give you a question to apply. How to use the formula, we'll teach you how to use the. Guys, follow me. We have just said that we don't want to use k as a constant. K can be replaced with 1 over 4 pi e. And we know what pi is now. What's pi class? 22/7, right? Or in decimal 3.142. In decimal 3.142. Class. So if I don't want to use k, I will come in here and say f is now equal to what? Q1, Q2, all over r square. We replace k with what? Times 1 over 4 pi e. Because k is what? So instead of k here, I play what? 1 over 4 pi e, giving you Q1, Q2. Q1, Q2 times 1 is Q1, Q2, right? All over 4 pi e naught r squared. 4 pi e naught r squared. This is another formula for Coulomb's law, force F. For class, the exam is, if it's 112, is the exact exam pattern which is 101, first semester. So the way the exam came first semester for physics is the way it comes second semester. I also expected to give you practical questions like first semester. Class, your set was the first set exam on practicals. You know you are given 2 papers, right? Your SAP is 102 first. Then the SAP is 101. I think you also be SAP the same thing. So the first practical will come as appetizer. Then the main course will come in. Main course will not come in after. How many questions were you given for practical first semester? 25, if I remember. 25, right? Yes, 25. Each question carries 2 marks. That's 30. So that's practical. Then your main exam came 35 questions, right? Yeah, I think they missed a mixture of OBJ and subjective. Remember, the first 25 was OBJ. The last 10 was subjective. Yes. So expect the same. Now follow me. So since your exam is OBJ predominantly, you do not need to use 1 over 4 pi e naught. Just use k as 9 times 10 raised to power. But it's important I inform you that k is also the same thing as 1 over 4 pi e, where e naught is called absolute, and it has a value of a constant 8.85 minus 10 so minus. Class, there's also a case where the 2 charges are the same. When the 2 charges have the same magnitude. Class, when the charges are the same, don't need to say Q1, Q2. Class, this Q1, Q2 means that the charges are different. They are what? When charges are the same, it's Q, Q. Since they're the same, why are you calling them different things? So our formula will now be F equals to K, Q, and Q again, right? All over R. Q times Q. All over what? K, Q square. All over what? R square. When the charges are the same, this is the formula K, Q square all over R. When they are different, K, Q1, Q2, all over what? Class, are we still following? Are we still following?
Yes, sir.
You still have strength now. The semester just started. By the time you do 3 chemistry classes, climb down from upstairs for 3 weeks. You know what's up, right? So this is your strength where now. Follow me. K Q square over R square or Q square over 4 pi E naught R. You know why I put 4 pi naught? Because K can be replaced with 1 over 4 pi E. K can be replaced with what? Good. K can be replaced with 1 over 4 pi E naught. Class. Quickly write the electric field. Electric field. Electric field, are you there? Follow me, no noise. Electric field is a region of space set up by a charge. Write down. Electric field is the region of space set up by a charge. Electric field. Is a region of space set up by a charge in which it exerts an electrical force on any other charge. Electric field is a region of space set up by a charge in which it exerts an electrical force on any other charge. Electric field is a region of space set up by a charge in which it exerts electrical force on any other charge. Class. Once there is a particular charge, and this charge exerts electrical force on any other charge, class, that region of space is already known as an electric field. This is an electric what? Electric field is a region of space set up by a charge. Follow me. In which it exerts electrical force on any other electric field. Are we together? Class, electric field mathematically can also be known as electric field strength or electric field intensity. Also called electric field strength or electric field strength. Follow me. Or electric field intensity. Class, let me just tell you the truth. This course will be the easiest course in the exam every year. It looks like it's difficult, but it's the easiest course in the exam every year. Physics are lenient with the exams. Like I was asking them last week, I was saying 2 weeks ago, which course was the easiest first semester? Most people said FSB and physics. Physics was what I was hearing. Physics, if you do your due diligence, put in your, they will give you the question as you study it. Are we together? Another name for electric field strength, electric field intensity. Well, mathematically, the electric field, right now, continue right, mathematical electric field is the force acting on a region of space per unit quantity of charge, Q. I'll come again. Mathematical electric field E, mathematical electric field E is the force F. Mathematical electric field E is the force F acting on a region of space per quantity of charge, Q. Class, mathematical electric field E is the force F. Mathematical electric field E is the force F acting on a region of space per quantity of charge, Q. Per quantity of charge, what? Q. Mathematical electric field E is the force F acting on a region of space per quantity of charge, what? Q. So, class, if you have to calculate the electric field strength, calculate the electric field intensity, or calculate the field, expect to get the force and the Q. So E equals to F divided by Q. Class, are we together? Write an electric dipole. Electric dipole. Electric what? Dipole. Electric dipole. Electric dipole, class. Electric dipole, are you there? Why are you spelling as dipole? D-I-P-O-L-E, right? D-I-P-O-L-E. 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 Electric dipole. Electric dipole. Electric dipole. This is an arrangement of two charges of equal magnitude. Electric dipole. This is an arrangement of two charges of equal magnitude. This is an arrangement of two charges of equal magnitude, but opposite directions. Two charges of equal magnitude but opposite directions. Each separated by an equal distance from the origin. Each separated by an equal distance from the origin. Each separated by an equal distance from the origin. Each separated by an equal distance from the origin. Each separated by an equal distance from the origin. Electric dipole is an arrangement of two charges of equal magnitude. Electric dipole is an arrangement of two charges of equal magnitude. But opposite directions. Two charges of equal magnitude opposite directions. Notice. Each separated by an equal distance from the origin. The distance from this charge, the charges are equal but opposite signs. This one is positive, this one is negative. So if this is 5, this is also 5. But this is plus 5, this is minus. So this is plus 5 Coulomb, this is minus 5. So opposite directions. Remember that from the origin up is positive y. Origin down is negative. That explains for why q is positive here and q is negative. Please follow carefully, follow. But the distance from this q to the origin is the same as the distance from this q to the. So let the distance from these two of them be AA because they have the same distance to the origin. Class, we will be asked to calculate the electric dipole moment P. Right now, electric dipole moment P. Electric dipole moment P is electric dipole moment P. The formula for electric dipole moment is 2A times Q. 2A times what? Now what does A represent? Distance of the charge from the origin, right? Distance of the charge is from the distance of the charge from the origin is A. What does Q represent? The quantity of charge. Write an electric field point. Electric field point. P. Electric field point. P. Electric field point P is the point at which the electric field is being determined. Electric field point P is the point at which the electric field is being determined. Electric field point what? P is the point at which the electric field is being determined. Are we together? Electric field point P is the point at which the electric field is being what? Right now, test charge Q naught. Test Q naught. Test charge Q. Test charge Q naught. Is a small positive charge placed at the electric field point. Is a small positive charge placed at the electric field point. Is a small positive charge placed at the electric field point and is used to determine or measure the electric field at that point. Is a small positive charge placed at the electric field point and is used to determine or measure, and is used to do what? Determine or measure the electric field at that point. It's used to determine or measure the electric field at that point. It's used to determine or what? Measure the electric field at that point. Class. Electric lines of force. Electric lines of force. Electric lines of force. These are imaginary lines drawn that shows the direction of the electric field. Class, electric field is a vector quantity, have direction. These are imaginary lines drawn that shows the what? direction of the electric field. These are imaginary lines drawn that does what? Shows the direction of the electric field. Imaginary lines drawn that does what? Shows the direction of the electric field. Imaginary lines drawn that does what?
Shows the direction.
Exactly. Now write down properties of electric lines of force. Another name for electric lines of force, they also called electric field lines. Electric field lines. Electric field lines, also called electric lines of force. So they're known as electric field lines. What are the properties? How do you identify electric lines of force? Properties. Are you there? Subheading, properties of electric lines of force. Properties of electric lines of force. 1. Are you there? One, the tangent to the lines of force at every point gives the direction of the field. The tangent to the lines of force at every point gives the direction of the field. The tangent to the lines of force at every point gives the direction of the field. The tangent to the lines of force at every point gives the what? The direction of the field. 2. Class, in the objective part, they can easily ask which of them is not a property of electric lines of force. What's the name for electric lines of force? Electric field lines. Electric field. Class, this thing we are doing now is what some people will do 1 week to exam. Like first semester, some people learn a full course for the first time, that one last week to the exam. So normally this marathon, we usually do it close to exam, but we decided to change it this time around. So imagine you have already done this now. Then the second time, we're going to provide this course again, definitely. But when your practical starts, you will reduce the number of times you come for tutorials. So you can focus on your practical and your lecture together. Once your practicals are over, we are going to take each of these courses again and cover them again one more time. That's the idea. So by the time we're covering for the second time, it won't be too new to you, right? Some of these words that are straight now will now be more familiar and you do better. So class, I said 2. The lines of force are continuous. Have you written that? The lines of force are continuous and they start on positive charges and end on the negative charges. The lines of force are continuous and they start on positive charges and end on negative charges. The lines of force are continuous and they start on positive charges and end on negative charges. The lines of force are continuous and they start on positive charges and end on what? Negative charges. Are we there? So the lines of force start from positive and end in very important. They start from positive charge and end in what? 3. The lines of force do not touch or intersect one another. The lines of force do not touch or intersect one another. The lines of force do not touch or intersect one another. The lines of force do not touch or intersect one another. The lines of force do not touch or do what? Four. They are constantly in a state of tension. They are constantly in a state of tension. The lines of force are constantly in a state of what? Tension. Which causes them to tend to shorten. 4. The lines of force are constantly in a state of what? Tension. Which causes them to tend to what? Shorten. The lines of force are constantly in a state of tension. Which causes them to tend to shorten. Five. The lines of force are drawn. 5. The lines of force are drawn such that the magnitude of the electric field. 5. The lines of force are drawn such that the magnitude of the electric field,
The max.
5, the lines of force are drawn. 5, the lines of force are what? Such that the magnitude of the electric field is proportional to the number of lines. Is proportional to the number of lines crossing a unit area. The lines of force are drawn so that the magnitude of the electric field, the lines of force are drawn so that the magnitude of the electric field is proportional to the number of lines. Is proportional to the number of lines crossing a unit area perpendicular to the lines. 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 Write down charge density. Charge what?
Density.
Charge density. Under charge density, write down linear charge density. Under charge density, write down linear charge density. Are you there? Surface charge density and volume charge density. Linear charge density, surface charge density, and volume charge density. Linear charge density, surface charge density, and volume charge density. Linear charge density, surface charge density, and volume charge. Class, the linear charge density, so there are 3 types of charge density basically, right? Linear charge density, surface charge density, and volume charge. Follow carefully, follow carefully, follow. The linear charge density is the change in quantity of charge all over change in length. This is the symbol for linear charge density, lambda. Lambda. The lambda symbol. Linear charge density is delta Q all over delta L. Linear charge density is change in quantity of charge all over change in length. Surface charge density is represented with the sigma symbol. Change in quantity of charge all over change in area. It's called surface area charge density. Surface area charge density. Change in quantity of charge all over what? And volume charge density is represented with the symbol rho, the rho symbol. Change in quantity of charge all over change in what? Volume. Plus, I hope you know that if you still see dq all over dl, it's still something has changed, I mean. dq dl means changing q all over changing. So if you go to your test, they are saying d instead of changing, it means the same. D means dq dl. Difference in q, change all over. So you can either use d or use delta to represent change. Class, I think we are giving you all important formula for chapter 1. And we're done with chapter 1. We just need to take questions. Let us take what? Let us take questions. Calculate the value of 2 equal charges. Calculate the value of what? 2 equal charges. If they repel each other. Calculate the value of 2 equal charges. If they repel each other with a force of 0.1 Newton. Calculate the value of 2 equal charges. If they repel each other. If they do what? repel each other with a force of 0.1 Newton. Calculate the value of two equal charges if they repel each other with a force of 0.1 Newton. When situated 50 centimeters apart in vacuum. When situated 50 centimeters apart in vacuum. I'll come again. I'll come. Calculate the value of two equal charges. If they repel each other with a force of 0.1 Newton, with a force of 0.1 when situated 50 centimeters apart in vacuum. When situated 50 centimeters apart in vacuum. Another question. I just came again, get from someone beside you. Another question. Find the electric field at a point. Find the electric field at a point 20 centimeters from a charge. Find the electric field at a point 20 centimeters from a charge. Find the electric field at a point. Find the electric field at a point 20 centimeters from a charge. Find the electric field at a point 20 centimeters from a charge of 20 microcoulomb. 20 centimeters from a charge of 20 microcoulomb. 20 centimeters from a charge of what? 20 microcoulomb. $20 centimeters from a charge of what? 20 microcoulomb. Are you there? Also, continue writing. Continuation of the question. What force will the field exert on a charge of 5 microcoulomb placed at that point? What force will the field exert on a charge of 5 microcoulomb placed at that point? What force will the field exert on a charge of 5 microcoulomb placed at that point? What force will the field exert on a charge of what? 5 microcoulomb placed at that point. Are we together, class? Another question. Calculate the force of attraction between an electron and a proton. Calculate the force of attraction between an electron and a proton. Calculate the force of attraction between an electron and a proton in a hydrogen atom. In a hydrogen atom. Calculate the force of attraction between an electron and a what? Proton in a hydrogen what? Atom. Assuming their distance of separation is 5.3 times 10 raised to the minus 11 meter. Assuming their distance of separation is 5.3 times 10 raised to the minus 11 meter. Assuming their distance of separation is 5.3 times 10 raised to the minus 11 meter. We ask to calculate the force of attraction. Calculate the force of attraction between an electron and a proton in a hydrogen atom. Class, why is there attraction instead of repulsion? They are unlike charges, have it? Electron is negative, proton is, so they will attract. They will do what? Yes, those examples should do. I've screened the question and we. So now follow me. Class, no noise, class, no. Look up. I want to remind you of something, class. Follow me, follow me, follow me. According to Coulomb's law, the force F equals to K if the quantity of charge at the same is Q square, right? All over R. According to Coulomb's, please follow me. Electric field E is F all over Q. I want to write on that formula that I have not mentioned.
That's what
Follow me carefully. Electric field intense to electric field strength E is electrical force divided by Q. Remember when I gave you this formula? The electrical field E is the force per unit charge Q. Meaning that the unit for electric field must be Newton or force is Newton. Quantity of charge per column. Unit for quantity of charge is what? So unit for electric field is Newton per. But electric field is F over Q, right? Follow me. But based on Coulomb's law, F is KQ square over R square. Do you agree? F is what? KQ square over R square. So can I replace this F with KQ square over R square? Means that my E will be KQ square all over R square all over. Do you agree? Because I replace F with KQ square over R square, but I still have another Q below. Do you agree? So that we do everything together, what we're going to have now is K Q square over R square. This all over means divided by Q, right? So we're going to have K Q square all over R square. If this division changes to multiplication, what will happen? Times 1 all over Q. Because when this division changes to multiplication sign, Q will come down. You agree? Good. What happens last is that this Q can kill one Q here, right? Leaving only one Q. So what's now remaining in class? KQ times 1, KQ, right? KQ all over R. So class, from Coulomb's law, we can derive the formula for electric field strength, electric field intensity as KQ all over R squared. E is KQ all over what? But don't forget, class, follow this. Okay, if I overcomplicate things. I want to write formula form. So this formula, the fact that we derive this formula does not mean that this other formula does not still stand, right? It's just giving you options. In case the parameters you are given doesn't suit this formula, you can switch. You can do what? Later on, I'll give you one more formula for electric field. E. Because electric field E is also electric potential per units per length. Electric field E is the quotient of the electric potential V. Electric field E is V all over R. Where V represents potential or voltage. Potential, electrical potential. Electrical what? And R represents distance. R represents what? So what makes physics difficult is they give you a question and you don't have the right formula for that question. That's what makes physics difficult, right? Yeah. You know why I like physics? Physics problem is straightforward. Know the formula, get the. Know the formula, understand how to use it, get the. Check, you see there are not really much notes, it's just formulas and application. Formulas and apply. Except when I have to explain electric field lines, electric dipole, yes, small notes here and there. But the main thing is formula and apply. Formula and potential all over this electrical potential divided by distance, also electric field. Imagine they gave you V and R and say find E. If you didn't know this formula, you don't know how to use it. Meanwhile, the only formula you know of electric field is F over Q, force over quantity of. But derive now that electric field can also be what? F over Q. But F is KQ square over R. So if we replace this F with KQ square over R square, E will be what? KQ square over R square divided by what? And if you do all the jargons, nobody has to derive this. OBJ. Just the formula I should get to this. E is KQ over what? Are we together, class? E is KQ over R squared. And E is V over R. V over what? I just thought to mention all this before we leave chapter 1, before we leave chapter. Class, we have 3 questions on our book, right? Yes. Let's demystify them and then move to chapter 2. Class, congratulations, we're done with chapter 1. Congratulations, we're done with chapter 1. Can we solve 3 questions, class? Can we ask first? What's the first question? Let's go. Calculate the value of 2 equal. So since they're equal, let's just call them Q, right? Yes?
If they repair each other.
If they repel each other.
Yes. For
them to have repelled each other, it's because they are equal, right? Yes. Like charge. Equal means like charges. Yes. What's the first law of electrostatics? Like charges repel. Unlike charges. If they repel each other, continue.
With a force of 0.1 Newton.
So the force of repulsion is 0.1 Newton. Yes, continue.
When situated 50 centimeters apart.
So distance between the two charges. So there are two equal charges, but they are situated apart. R is the distance between the two charges. Class, are you following?
Yeah.
How many meters apart?
50 centimeters.
50 centimeters. What does 50 centimeters tell us to do? Convert to meter. Convert to what? Never use your distance in centimeter in pieces. It's not today, we know that, right? How do we go for centimeter to meter? We divide by 100. Divide by 50 divided by 100 gives us what? Now, class, this already tells us to use Coulomb's law. Coulomb's constant K is 9 times 10 raised to the power 9. It's a constant, right? Whether they give you or not, you should know. Class F equals KQ squared all over what? R squared. Class follows. But it's Q we are looking, so we have to make Q instead of the cross. So we have KQ squared equals to F R squared. Please follow. KQ squared equals to what? Divide both sides by K. So that K cancels K. So that Q squared equals to what? All over. Can we find square root of both sides? So that Q can be alone. But anytime a square root means a square, they cancel each other. Anytime a square root means a square, they cancel each other. So I left the Q equals square roots FR square all over. Everybody in this square root will have it, right? Who is F? Who is R? 0.5. Or who is K? 9 times 10 raised to power. Since we have everybody inside the square root, we can easily get our answer, right? We can easily get our answer. Go ahead and get the answer. Go ahead and get the answer. Give me the final answer quickly. Quickly. Comrade. Come. Let me get water as you're going. Cold bottle water. Get cold bottle water for me. From this woman. See you. Final answer, what's final answer, class? So we have 1.67 as the final answer, we have solved. 1.67 as the final answer. Are we on the same page? What did you get?
1.67 times 10 raised to the power 8.
Times 10 raised to the power what?
Minus 6.